So welcome all for this workshop. Thank you for your attendance. We are going with Louise to present you the roadmap towards energy mix diversification and possibly self-sufficiency. So this is the work package 7.5 of the Portos project, and it's an action that has been performed by INNOSEA, a French engineering consultancy company specialized into marine renewable energies. And so we used to work with a lot on offshore wind, floating solar, and wave energy, and for RED projects. Next slide, please. So after a short introduction, we will go over the methodology that we developed within this task action. So the methodology is basically the main outcome of the action. It aims to provide a tool for the European ports that would like to create a roadmap for their energy transition. And then we will show you some results based on the three case studies that the three first case studies. Yeah. Next slide, please. So before considering mixed diversification, the first step is assessing the port energy consumption to have a better overview of what are the energy needs at the port, what are the usage in terms of electricity, fuel, and gas. So then once you have insight on which energy you need and use, you can do some savings and also do some optimization of your process with energy efficiency. So basically it aims at providing the same service but with less energy. And then after considering these first steps, you can look at the mix diversification. So because you know which energy you really need, so you know where you need to focus on. So for this task action, the roadmap towards energy mix diversification and possibly self-sufficiency, we made some assumptions. So the mix diversification has focused on the electrical needs only. So this is associated to some topics. So first, the greenhouse gases emission reduction by shifting the electrical mix towards a more sustainable one based on renewables. But it's also linked to electrification topics and decrease of fossil fuel dependence within the ports. And then the target of the roadmap is the self-sufficiency. So the self-sufficiency here is considered as the being the equation that you can see. So the total annual consumption in terms of electricity at the port must match with the total annual production at the port. So there are some topics that are related to this target, which are the storage, for example, to have a resilient electrical system. Hence, to consider this axis of roadmap, you need to take into account the actions that are already carried out at the port, in order to take into account the fact that some actions may already have started at the port or in the region. So one last main message for this introduction: the port is an energy consumer, but it's also a land planner and infrastructure provider. So The main idea here is that the port can make its land available to renewable energy projects. It will so by doing so, it will reduce its impact in return for a rent. So money for the port, but also it can support the experimentation of less mature renewable energy technologies such as wave energy.
So yeah, thank you for the introduction, Matteo. So now we will present you the methodology that we have defined in order to set up a roadmap for a given port. So we define 7 steps in order to do so, and we will just go and explain them one by one. So the first step is to understand the strategic context of the port. It means the different specificities. It can be the activities, the stakeholders. Is it more touristic, more industrial ports, both, for example, the current and the future consumption of the port? Do they plan to electrify, I don't know, vehicles or something? Why they are performing they want to perform their energy transition? Can be many different reasons. Is it only to meet regulatory obligations, or is it really a voluntary adoptions? We can also identify the different challenges that have been that will have to be faced. So here, really, the point is to understand the port. So here, yes, it just as Matteo said, in the scope of the Portos project, we applied our methodology to 3 case studies. 1 port in Ireland, 1 port in Portugal, and 1 port in Spain, Port of Vigo. So here, just a quick overview of the several information that we have gathered. We discuss a lot with the port in order to understand their strategic context. So now let's move to step 2. Now we know the port and its specificities, and we want to set up the main ambitions of our roadmap. To do so, we use what we call scenarios, low, medium, and high. The aim here is to really quantify the objectives, so with, for example, indicators of achievement, and a timeline, an associated timeline. So in the scope of the Portos project, the ambition chosen was to perform electrical energy transition within the port, as Matteo explained. So basically, from the port point of view, it's a little bit going from a national grid consumer to a renewable energy producer. So here I just wanted to show you what we have performed with the 3 case studies ports. As you can see, we define scenarios which are quite different between the ports. As you can see here in green, the percentages. But the timeline is very similar. And this is because the roadmap of the ports are really driven by European objectives, in fact. So yes, we just say that the step 2 is to define the ambition with the scenarios. Let's move to step 3. So now we need to break down these big objectives, let's say, this ambition, into structural objectives. So structural objectives are like the main areas of action of your roadmap. So here in our case study, we identified 3 structural objectives. The first one is about carry out the feasibility studies. The second one is how to create a dynamic behavior and to involve the stakeholders, local stakeholders, in the implementation of renewable energies in the port. And the third one is really how to implement and install the identify projects in the port. So these are, again, structural objectives. And now we need to go to operational objectives. So this is a step 4, to be more practical and more detailed. And these operational objectives are then broken into really detailed actions. So, for example, in our case studies, we ended up with more than 50 actions at the end. So, very, very detailed. Okay. And in fact, here in the definition, very detailed definition of the actions, we need to take into account the other vision and other axis of development of the port, like, for example, electrification, GHG reduction, for example, of the port, because most of the time there are synergies between our roadmap, which is about the mixed diversification, and other roadmap of the port. So if we want our roadmap to be relevant and efficient, we had to think about this other axis of development of the port. So yes, at the end, we have a lot of different action. So in order to make the roadmap more readable, we use some color legend. So for example, here in orange, it's actions that are required to reach and achieve low-term scenarios that have been defined. In green, it's actions that are only required to reach long-term scenarios. And in blue, it's all the actions that will be required to reach all scenarios. And then we have a second color legend. We define what we call family of actions, in fact, because an action can concern something to conceive, like just make a study about something. Then we have inform and mobilize, and then act. So this color legend is very important, for example, for decision maker. When they read the roadmaps, they can see quickly what is it about. So here it's an example on the on the port in Ireland. As you can see, there are many details, and here we can see quickly that we have a lot of green. So links with the these operational objectives, which is how we implement the selected renewable energies, we will have a lot of actions. Mathieu,
I can take.
Okay.
Yeah, I can take this. So then, based on the wide list of actions that you have, so between 50 and 70, depending on the port, you must prioritize them. So hence we do a scoring of the actions based on 3 factors: the technical feasibility of the action, the cost feasibility, and the structuring impact in terms of development of renewable energy at the port. So can you go next slide, please, Louise? So based on this scoring, you can introduce the action plan. So the step 6 of the roadmap. This action plan aims at representing all the actions on the flowchart that links the action in terms of temporality and dependence between them. And in this flowchart, you use again the colors presented in the previous sheets. So like this, you still have the idea of which action refers to what kind of activity for the stakeholder that needs to perform the action. So here, for example, it's the flowchart, the action plan for the case study of Vigo. And finally, the last step of the roadmap is to give for some of the actions, not all of them, but the one considered the most important, rather in terms of priority or in terms of structuring impact for the development of the renewable energy at the port. You perform an action sheet like this. So in this action sheet, you can you define the target, who will benefit from this action. You can define the different steps to perform the action. Involve the stakeholders. Sometimes it's not the port that is the main stakeholder that needs to perform the action. Sometimes it can be rather the local stakeholder, company, or government. You can also define some key performance indicator to have a follow-up of the action to know how it is progressing, and also the status, because some actions may already have been started at the port, so you need to consider this. So, for example, here you can see quite exhaustive action sheet for the case study of Ireland, and here for lectures.
So yes, that was the presentation of the methodology with the 7 steps. And now we just wanted to show you some results, if it works. Okay. So here it's the case study of the port in Ireland, Shannon Foreign Port Company. So in the end, we have the first big phase, which is the feasibility study. So basically, firstly, we have the pre-feasibility study. For the case study of the Port of Shannon, these studies have been performed in the scope of the Portos project, in fact. So we need to assess the renewable energy resources. Do we have enough solar radiations, enough wind resources, wave resources, etc. We need to list the main constraints. We need to understand the energy demand. And once you have this, you will need to list all the potential renewable energy projects that you could implement at your port. So at the end of this big step, you have a list. And then you need to choose the best projects according to your ambition and your scenarios that you have defined. So how to do this? In fact, we use this kind of graph. So here you have the timeline. Here you have the annual energy product. And you can add here a recall of your objectives, scenario objectives. So here, for example, in 2025, we want to produce annually 133 megawatt hours. So low scenarios, medium scenario, high scenario. And then you can just add on this chart the renewable energy projects that have been identified, and when we will be able to implement them. So for example, here we have a small onshore solar project, which could be installed at the port, let's say at the end of 2023. Then we had another onshore solar project, bigger, which could be installed in 2024. And then there was a bigger onshore solar project that will be installed in 2028. So by doing this, you can see that in fact the low scenarios will be reached quickly thanks to onshore solar. Then the medium scenario will also be reached thanks to onshore solar and a little bit of wind projects. And in fact, when we will reach the medium scenario with the wind turbine, we will directly reach the high scenario. So yes, this is very useful. So now we need to understand, to know how to go to, okay, we select some projects that are relevant according to our ambitions. How do we implement them in the port? So here we have again the solar projects, here the onshore wind project. And here in green, it is a long-term vision of the port. In fact, for this case study, at the long term, they wanted to be involved in the floating wind development in their region. So we add it here in green as a long-term vision. So how to get there? Thanks to what we called development and construction loops. So basically, the main big steps for every project will be the same: development and then construction. So one is required for solar, one for wind, and one for floating wind. Of course, the timeline of this loop will not be the same. For a solar, a small solar project is much quicker than for example, floating wind. So yes, and at the very end of the roadmap, we have what we call a summary chart with really the main information of the roadmap. So here we have again the timeline. Here we have the percentage of self-sufficiency, that is to say the amount of electricity produced compared to the amount of electricity consumed by the port. We add here again the objectives for the low scenarios, medium scenario, and high scenario. So here is a recall of the vision of the ports. So the port wants currently to really compensate only their current electrical needs. Then they really want to be involved in their energy transition and go a little bit beyond this by considering a possible raise in their consumption due to electrification. And then at the end, as I said before, they want to be involved in the floating wind development. So then we just, it's very simple. We just put the projects that have been identified. So here again, the solar project, wind project, and at the long term, the floating wind project. Then we just add our development and construction loop. So one here is required for this project, another one. And then we add the action with the highest priority. So for example, in this case, it was these actions. And also for the long-term vision. So just quickly here, for example, these actions, which are only required to reach the long-term vision of the port, need to be started now. So this chart is nice because you know by following the timeline which action you need to start and when. So yes, that was the main results. And that was the conclusions.
So when meanwhile we were doing this roadmap, we were in a close interaction with the ports, and we identified common concerns for the 3 case studies. So First, the ambition and the objectives of the ports are driven by the European obligations and legislative package such as the Fit for 55 package. Based on this obligation, many ports are considering, for example, cold ironing, so onshore power supply for the ships that are moored at the quay. They are also considering the use of alternative fuels for the cranes, the machine at the port, and also the transport, and also the use of renewable electricity, either using a power purchase agreement from the national grid or by installing renewable energy systems at the port on their lands. It is also, so this topic is also a challenge for the ports because it's not the main activity of the ports. Sometimes there is a lack of budget or dedicated time for this. Sometimes, depending on the size of the port, there is a lack of skills and knowledge. So it really depends on the type of the port, the organization size. Sometimes the port may have a sustainable department which can dedicate some time and money on the energy transition topic. And the renewable energy projects can be also an opportunity to bring new revenues for the port. Besides all the three case studies, we're considering an increase in their energy consumption in general, but particularly in electricity consumption. So there is this is still taken into account in their roadmap. So based on their planned increase of activities and the electrification of the usage.
I can present.
Okay.
So just here we know that it's a lot of information today, and it's, I think, like the last last day of this seminar. So we just summarize here the 6 main points for us, the most important points about set up a roadmap toward mixed diversification. So quickly, the first one is that the roadmap must be defined in close collaboration with the port in order to be realistic and achievable, especially in the definition of the scenarios. The second point is to use scenarios to try to define objective in phases. So it can be good to have first projects that can be quickly implemented. So you have first results, and you can also try to involve local stakeholders and so on. But it's important also to stay ambitious in the long term, because we know as the European scale, we will need to stay ambitious to reach and to achieve our transition. The third point was, Matteo already presents this point a little bit, but in the action sheet, it's really important to identify the right stakeholders to lead the actions, because the port will not be able to lead all the actions. It's not possible. So try to know well the map of the stakeholders. And then we talk about some ports that just want to they told us that they will in the first phase buy green energy from the national grid. through dedicated purchase agreement. But we think that in order to gain in autonomy for possible additional incomes, and because we can participate in the transition, it can be a really good opportunity to try to install renewable energy projects on the port facilities. Most of the time, ports have some big places, for example, industrial buildings, and we can just add some solar panels on their roof. So it's kind of win-win contract. And yeah, we also talk about the fact that it's interesting to couple the installation of renewable energy projects with some projects such as the onshore power supply or production of alternative fuels. I think this is really linked and very interesting to link them. And the last point is just that we really try to discuss with the port and based on it to have a generic methodology that can be reused easily by other ports and for other roadmap related to energy transition. So we hope it will be the case. So yes, that was the conclusion. And yes, just for you to know, we will apply this methodology to 2 additional ports. So the port of Ponta Delgada, I think it is where you are currently, and the port of Granadilla in Tenerife. So for now, we have a big picture, I think, and a good strategic context understanding of the port of Ponta Delgada. But we need more discussion with the port of Granadilla to really understand their objectives and their visions. Thank you for your listening. And if you have any question.
At the end of this presentation, we will allow any question from the audience. Is there any question, please? A question? Okay.
Hello, Louise. This is Gian Maria from Porto. My question is, concerning your roadmaps for new case study ports as islands, which main challenge have you found for your preliminary assessment?
I can take this one, Louise, if you want.
Yes, go on.
So first, for the case of Granadilla, we really need more information in terms of what are the concerns and also the current activities for the mix diversification at the port, what is currently done. And also, well, not only mix diversification, but also more globally in terms of energy transition. And for the port of Ponta Delgada, we have identified some concerns, but that will probably be the similar ones for the case of Canada, is that as it is islands and the local grid is not connected with the mainland, so this local grids rely still a lot on fossil fuel. And there is a lack of land available at the port to reach the self-sufficiency. So there isn't enough available resources to produce the same amount as the energy that is consumed. So if there is for example, an increase in terms of electricity consumption, it will be very hard in the future to match the electricity production with the electricity consumption. And also, if there is if there is a lack of space for the energy production, there will be some lack for the energy storage as well.
Thank you. Thank you.
Any other question from the audience, please? No? Just to say thank you to you. Roadmap towards energy mix diversification and possibility self-sufficiency. Thank you very much.
Thank you.
Thank you.
Well, we are now just waiting a few moments to try to have connection with Ireland for the presentation with the title of Decision Support System Tool Presentation and Application from MaREI, SFE Center for Energy, Climate and Marine from University College Cork. Are you there?
Yes, hello. Can you hear me and see my screen?
Yes, loud and clear.
Very good. So
go ahead,
my
please.
name is Nathan Kirwan, and I am going to present the decision support system that MaREI put together for work package 7.4 of the Portos project. So, as we all know, seaports play a crucial role in global economics. 90% of global trade is delivered by sea. So the transportation of goods and raw materials are essential to our economies. And as we move towards a more sustainable resources, seaports will continue to play an important role in the supply chain and development of the offshore wind industry that is accelerating at the moment. So seaports are also going to be part of assembly, storage and O&M vessels. So it all ties into just making seaports more sustainable in how they operate in themselves. So this tool looks inwardly at their own energy consumption and where they are getting their electricity power from. So we have built a decision support system that'll help seaports decide which type of renewable energy they should invest in, whether it's solar, wind, tide, or wave energy. So what you're looking at the moment is a screenshot of the homepage of the decision support system, and the link is on the top left-hand side. So this tool is an open source tool and it's free to use. And we would encourage all seaports to have a go of it and see if what kind of results they get. So at the moment, the tool is being validated by 2 ports, Falmouth Harbour and La Rochelle. So I'll just explain how the tool is used. So on the top right hand corner, there are some instructions, and it'll give you an option to download some instructions as well. And then if you need some guidance, there's a contact us tab as well, where we can answer any questions. After that, you're just putting in the name of your port, the energy consumption of your port per month. So we're looking for your average energy consumption, and that can be put for each month, and that is put into this section here. And you can put in your current energy consumption, or if you can forecast it, if you think your energy consumption is going to go up, you can also put in forecasted energy consumptions. And then next you put in the name of your country and your carbon intensity. And again, those the carbon intensity of your country is in the instruction manual. But also your carbon intensity could change over time, so it's important that you get the most up-to-date carbon intensity value. So after that, you're looking at your port, and you would know yourself what kind of resources are available. If solar, wind, tide, or wave. So some ports won't have any tidal resources available to them, and some ports won't have wave. And in other cases, wind might not be an option. So the solar data that we're looking for is the total panel area. So initially, seaports might have a look at the space available with regards to the rooftops of warehouses. So that sum can be put in there. And then the average solar radiation for your area is the next input. And then the yearly downtime for the solar panels. So that just includes any maintenance that might require the panels to be shut down for a period of time, and that's just a percentage. And then the efficiency of the solar panel then is also an input, and that will be based on the model that is available to you in your area. And the performance ratio is also part of the solar panel package as well. And then the next four inputs are all to calculate the LCOE, the levelized cost of electricity, and the inputs required there are total yearly and O&M costs, total yearly technician salaries, additional costs, and then the total number of operational years. So there are the inputs for the solar data. And then next, we have a look at the wind data. So the turbine size is based on your annual energy consumption, and you can put that in the first box there. And then the total yearly downtime, again, that's might be down for maintenance, and that's a percentage input as well. And again, the next four inputs are based on the LCOE as well. And then the total number of operational years for the wind turbine. And then once you have those inputs put in, you can submit it. And then we're looking at the average, the monthly average wind speeds next for each month. So again, the further back you can go with data. So 20 years data is what gives the most accurate results. But if you only have 1 year or 5 years or however many you can pull together, you can put that in here. It's important to say as well, in the instruction manual, we give links, open source links to where you can get wind data and wave data and some solar data as well. So the next is tidal data. So your wind turbine or your model size goes in here, and then the yearly downtime for maintenance goes in as a percentage. And then again, we have some LCOE calculations as well, O&M costs, technician salaries, yearly and additional costs that might be incurred, and then the total operational years. And then here we're looking for neap and spring tide values as well for each month, and then that is put in as well as an input. And then wave data, we're looking at wave height and wave period data. And then as there are different types of wave energy converters, we give some guidance percentages as to what is applicable for those different types. So whether it's an oscillating water column or an overtopping device, if you have a more accurate power takeoff efficiency percentage, you can use that. So then again, we're into LCOE costs. So yearly downtime, O&M, technician salaries, and then additional costs, and then again the total number of years, and then that's put in to the tool. And then the outputs for each energy type are the LCOE, the energy generated from that energy device, the CO2 emissions reduction in comparison to your previous, to where you're getting your energy at the moment. And then there's an overall comparison chart, breaking down which type of renewable energies you've actually inputted for. And then the results can also be downloaded, and you can keep them. And then if you want to change your inputs, you can compare and contrast different results in different situations. And then this is the LCOE formula that we're using. So that concludes my presentation. If anyone has any questions, I can take them.
Any question from the audience here in the Azores? No questions? No. Thank you. Thank you to you here, there in Ireland. Thank you.
Thank you very much. Thank you.
Well, the final presentation we have as the title, Good Practice Guide for Port Energy Self-Sufficiency and Sustainability from University of Plymouth, UK. We have 3 persons from Plymouth here, but I think we are going to have John Samuel from Plymouth.
Yeah, are you able to hear me? Are you able to hear me?
Yeah. Go ahead, please.
Yeah, great. So good afternoon, everyone. Myself, John Samuel, and I'm currently working as a research fellow at the University of Plymouth. Today, I'm going to present the Good Practice Guide for Port Energy Self-Sufficiency and Sustainability. Before going into the presentation, I would like to thank the Plymouth team, Dr. David Simmons and Dr. Joan Smiles, and Dr. Katrina Constantinu for their help and suggestions with this work, as well as for all the Portos project partners for their contribution as well. To set the context, the Portos project, the main objective is to evaluate the implementation and integrated use of renewable energies, such as wave, tidal, solar, and wind energy to attain energy self-sufficiency at Atlantic area ports. There are 2 environmental priorities has been addressed to reduce the greenhouse gas emissions and the reduction in the air pollution. So these are the partners involved in the project. This is from the first phase, and it does need to be included with the Port of Açores and Port of Tenerife. But as you can see here, the project partners are from not only academic, also from industry, the research institutions, and all partners work with the case study ports. Originally, there was 3 case study ports, Shannon Point's Port Comini from Ireland, and Port of Vigo from Spain, and Port of Alexios from Portugal. And now we have 2 more case study ports as well, Port of Tenerife and Port of Açores. So coming to the Good Practice Guide for Port Energy Self-Sufficiency and Sustainability. In this slide, I will explain about the structure of the Good Practice Guide and how it has been put together and how one can use it to understand the good practices that followed in the Portos project. So in the Portos project, the implementation of renewable energy in ports to achieve energy self-sufficiency has been evaluated through the 7 key elements. As you can see here, these are the 7 key elements It starts with multi-parameter characterization of the port, and followed with evaluation of energy consumption in the port. And it went on to identify the best areas and resources in support with high resolution modeling, and performing the cost-effective analysis to find the optimum technologies and site, and adapting to the infrastructures, as well as final environmental impact analysis and the economic assessment as well. There are a few of the details has been already presented before the lunch sessions. I made this presentation very shortly to the point so that we can understand the key elements of these good practices. So this good practice guide has been made in such a way that it provides a concise and generalized overview of these key elements. And also it has the appendix that expands the generalized discussion with examples of the work that carried out for the case study reports as well. So in the end of this presentation, we will invite you to review the good practice guide to provide your feedback, and we would like to further improve this guide as well, because it has not yet been fully completed. The main generalized details are completed, but when it comes to the appendix, we need to still complete. It's only completed about 80%. So the main idea is that the port stakeholders can use this guide as a starting point to understand the good practices that followed in the Portos project. For the last 4 years, the Portos project partners has been worked on these 7 elements. These are the core theme of the project itself, while evaluating the renewable energy implementation in the port. So this has been essentially summarized in a guide. It's about 10 to 15 pages of the summarization of the entire project, and it's supplemented with the appendix, about 100 pages with examples that carried out with the case study reports, and with the background reports of the Portos results. One can understand the whole work of the Portos project, and it can be applied to other case study reports as well. So essentially, this is a summation of all the work that has been done, and it concisely discuss the different elements as itself. I will go into I'm going to discuss the key elements in the following slides. Since we already discussed some of the details before the lunch session, I would like to keep it short, and so that we can have more time to review the guide to have your feedback as well. So to start with the multi-parameter classification of the port. So this is the first step in the evaluation of the energy self-sufficiency in the port. This aim of this task was to provide a detailed description of any information on ports that can assist in analyzing the energy consumption, evaluating the renewable energy options, and effectively modeling marine energy resources. So as you can see here in the 7 key elements, the energy consumption is the second stage, and analyzing the resources and selecting the cost-effective technologies are all followed in the next stages. So this is the first step. Try to gather as much as possible the important or key detailed information so that it can be supplied to other stages to go forward with evaluation. So there are the first one is the physical characteristics, and as you can see here, the port limits. So since we are looking at how port energy demand can be met, and also we need to understand what is the port limit, the legal limit of the port, wherein we can study the implementation of the renewable energy. So this is very important. And also we need to understand the navigational vessels, the navigation area, and so on. So this delineates the working area and the boundaries for the resource assessment as well. And followed with infrastructure understanding. This is very important in the sense, like, some of the renewable energy solutions, they need support from the infrastructure also, like breakwaters is one of the structure. the oscillating water column type wave energy converters can be integrated, and also we need to understand the electrical infrastructure within the port, so that that can be used to support the renewable energy implementation also. And also understanding of the hydromorphodynamic data also very important. It says it gives the information on the bathymetry. So the depth can have a large effect on the renewable energy implementation. Some of the technologies cannot be implemented in very shallow region. And also this section gives the important details of the wind and wave and the solar radiation and so on. So this is a very important parameter that needs to be thoroughly understand to go forward with other stages. So coming to the socio-economic context, so needs to understand the economic activity within the port area, so that when we try to implement the renewable energy solutions, that should not affect the economic activities around the port. For example, fishing, aquaculture zones, so and so needs to be understood clearly, so that it will not be affected while we go for renewable energy implementation. So again, health and well-being need to have a good understanding of the air pollution that is there around the port area, so that the local community can be benefited from renewable energy solutions. So it can be a good selling point for renewable energy implementation as well. And again, the ports are steeped in cultural and history. So there are important areas that we need to understand that needs to be preserved and not to be damaged while we try to implement renewable energy solutions. So these are all the different parameters that needs to be thoroughly understood before going forward with the renewable energy implementation. So some of the details are comes under the restrictions while considering for the renewable energy implementation. So in the following elements, I will discuss more on this as well. So the combination of the physical and socio-economic factors in port castration enables the effective planning and implementation of renewable energy solutions as well. So the first step, this is very important step in understanding all the relevant parameters to be supplemented to the other stages. And coming to the second stage, that is with evaluation of energy consumption in the port. So the steps in the process are collecting the data on energy consumption, also their consumption patterns, like whether it's a daily, monthly, yearly. We need to understand the variation, so that the relevant renewable energy solutions can be adopted, because the renewable energy solutions also intermittent. For example, solar energy cannot be produced in the night, and similarly, each resource has their own energy production cycle. So we need to understand the energy consumption profile, so that the relevant energy measures can be adopted. And also energy usage breakdown. The different energy consumption components needs to be identified, so that we can identify the energy saving opportunities. So we can suggest how it can be improved to increase the energy efficiency within the port also. And also the important aspect of this stage is to estimate the energy consumption within the port, so that this dictates how much the renewable energy that needs to be implemented to meet the energy demand. So this gives the good understanding of the capacity that needed to meet the energy demand. Also the mix of different resources, or it aids in the choosing of the different resources, considering the different variation within the port also. So once we know the consumption, what is the energy demand of the port, and we need to understand how it can be met. So there are different technologies available for each resources, like wind, wave, tidal, and solar. So we need to thoroughly scrutinize in choosing, or while choosing the technologies and the site. It's all comes down to the cost. So we need to choose the very cost-effective technologies and site. So in this stage, there are three elements has been put together. So the multi-criteria identification of best areas and resources that we discussed before the lunch sessions. So the different resources are analyzed using the existing open literature data. Different restrictions has been considered. As I mentioned, navigation areas should be avoided, and fishing and aquaculture zones should be avoided, and their economic activity should not be damaged, and leisure areas and the historical areas, and the water depth also needs to be considered while implementing renewable energy solutions. So this both aspects like resources and the restriction have to go hand in hand while choosing the best areas and resources as well. Once we chose the best areas and the resources, and it has been supported by the high resolution numerical modeling as well. There are different modeling software has been used, DERF 3D, Flow, and SWAN and Polyson. These are all used in their energy resource assessment. So in this guide, you would see reference to these modeling softwares and their application and the resolution in which they applied, and what are the important information that has been considered while doing so. So the guide gives a good overview of these informations in a very concise manner. So once we know the exact estimate of the power production, we can choose the cost-effective technology and the site based on levelized cost of energy and SWOT analysis. SWOT analysis includes the strength and weakness and opportunities and threat of implementing these solutions within the port. So not only cost, also consider it also needs to be scrutinized between different technologies also. So in this element, we are choosing the very cost-effective technology and site, and in the next stage, it has been taken further for how it can be incorporated into the port. Ports has the different infrastructure facilities. So once we arrived on the site and the technology, and we can work on how it can be incorporated in the port. Basically, we can build a new one if there is a space, or if there is a existing infrastructure available, it can be modified to include the energy solutions. So it starts with the analysis of existing renewable energy power plants, and we plan for the further infrastructure, basically the renewable energy solution that considered. And further, it has been analyzed for infrastructure adaptations, and also we looked at the partners looked at the synergies between different technologies, how it can be put together, and also the effect of climate change. And there are clear upgrade strategy also detailed in the guide itself. So for this modified infrastructure, the environmental impact analysis and the economic assessment and business plan has been conducted. Coming to the environmental impact analysis, herein the key environmental stresses are identified. It can be the air pollution and the noise pollution, so and so, that can affect some of the environmental aspects like flora and fauna and the animals and the birds and so on. So while implementing these solutions, one should take care of mitigation measures to protect these receptors. The cost of these projects has been analyzed in terms of net present value and return on investment as well. And finally, the business plan. So essentially, these are the 7 key elements that has been thoroughly followed in the Portos project. There are many good practices has been considered. So that has been summarized in the good practice guide. To summarize, there are 7 key elements has been identified, starting with the parameter characterization. That's a very important one, and understanding the energy consumption profile to make sure how much we need to implement the renewable energy solutions, and further go with the resource assessment and cost-effective technology site selection. In this guide, it has been explained about how the techniques has been carried out for the resource assessment, and also the mention of different softwares used and the resolution that has been incorporated, and so on. And different environmental impact assessment methods has been explained, and the financial analysis tool that has been used in the project as well. As I mentioned, there are three cases. The Portos project partners work closely with the three case study ports. For there are two more ports has been very recently added, but the work is still ongoing. We expect to incorporate those results as well in the good practice guide. But essentially, we have the appendix section to showcase the example of the different work that has been carried out. So there are challenges that has been faced by the partners, and during the challenge, the solutions, some of the solutions has been implemented, and those outcomes also mentioned in this guide also. And also this guide is supported by the Portos project reports and research publications and the online tools. So the 4 years of work that has been summarized in a very concise manner, about 10 to 15 pages, and also about 70 to 100 pages of the examples that has been detailed, and then many reports of the Portos project results can be supplemented to the evaluation also. So we hope that this good practice guide could serve as a starting point for port stakeholders to understand the good practices followed in the Portos project. The aim of which is to evaluate the implementation of renewable energy in the ports to achieve energy self-sufficiency. This gives a very starting point, and from here you can use the background Portos reports to analyze renewable energy implementation within the port, not only for the case study ports that we did, and it can be applied to other ports as well. So we try to make it very generalized as much as possible, and you can use this QR code to access the good practice guide, and we invite your feedback on the guide itself, and you can add your comments and what are you feeling, how it can be improved, and you can also email to my email address or my colleague's email address given here, and my colleagues are attending this presentation in person as well, Dr. David Simmons and Katharina Constantino, and they will be taking your feedback on this guide. Hello, Dave. Are you able to hear me?
I can hear you. Can you hear me? Hi, John. Can you hear me?
Yeah.
Excellent. I just wondered if we could put the QR code back up, John. Or if not, I can. So I think the aim of the session for us was to see whether we could get some feedback from you, and we just invite you at this stage to, I'm not sure if you could, I just want to open the feedback. John's got it up there, it's okay, we're okay.
Just put it back, hide the presenter's view. Oh, that's already done, I think.
Yeah, I think.
That's
so
what you want, right?
If nothing else, quite like you, if you could take a picture, you could have a go at downloading the guide, and you can actually edit it or put some comments on it for us, preferably over the next few days to a week, because we only have about a month to go to finalise it. So any feedback from members of the audience would be gratefully received, or from your colleagues. As John was saying, this is meant to encapsulate a sort of overview of the process that Portos has put together. and to signpost where you can find out all about the reports and the information that would allow you to delve deeper into the Portos project. So, unless there's any comments, thank you very much, and thank you, John, for your presentation on our behalf.
Thank you. Thanks.
Any question from the audience, please? No questions? Well, for the end of this workshop, we would like to invite the leader of the project, University of Porto, just for a few words.
Good afternoon. After 3 days of work, very interesting presentations and enlightening discussions, but also after experiencing the hospitality of the island and also tasting the delicacies of San Miguel, we reach the end of this series of events related with Portos. So this series is the last one. So it's a big and important event. I hope that we could build on the knowledge that was created during these 4 years, future collaborations that could put together the universities, the port authorities, and also the companies, trying to explore the synergies and trying to develop solutions for the problems and for the challenges that we have ahead of us in what concerns energy self-sufficiency and energy transition. To conclude, and on behalf of the coordination team from University of Porto, and also on behalf of all the Portos partnership, I would like to thank the opportunity to have this last series of events here in Ponta Delgada and the Port of Açores for hosting and for the very nice welcome and all the work they did to allow us to be here and to create this event a success. Thank you very much.
These 3 days of work are closed by the chairman of the board of directors of Portos dos Açores.
Well, thank you for the survivors of the 3 days of work. As you've seen, it's really hard to work in islands like ours because everything is difficult. We eat well, we live well, and working becomes harder each day we pass here, and we get fatter every day. But for your work, for your skills, thank you for sharing. It was an amazing event with a lot of sharing ideas, sharing knowledge, sharing, of course, experience, and a lot of work done before that could be shared with the quality that you did. For us, it's a privilege to have your skills and your experience here with us. It's, as you've seen, a good challenge to integrate all the communities in what we are doing. The actors are very spread throughout the islands. The islands have specificities which becomes more challenging even to implement innovative and ideas for the future that can help us to bring on better future for the port and, of course, for our societies. Thank you once again for all the work, all the commitment that you showed from everywhere that have been speaking to us. I would like just to end this act to call to the stage all the team that was with me, because some are spread around the islands, but especially Engineer Ricardo Batista, Dr. Luís Prieto, Doutora Francisca, Doutora Marília, Dr. Paulo e a Senhora Engenheira Filipa. So this is not all of us. We are 288 around all the islands, but of course this team was very committed the last few days and weeks to give you all the presentation. I'm spending Silvio out, but let me say that the video you saw was done and produced by Silvio, which is our local star of videos. And thank you for sharing these moments with us. It was a pleasure to have you here. Hope you find in your life in the future to come a way back to the Azores with your families and friends. If you want to, you're very well welcome, as you have seen, and hope to see you in the near future. Thank you very much.
Just to say, we have yet a short coffee break for you. Thank you.